All right. So no matter what course you guys took in grade 10, everybody did a unit on solving linear systems. So you guys learned methods like elimination or substitution. You guys remember doing stuff like that? I think the people that took 2P with me, we did elimination quite a bit. We didn't do a lot of substitution. But basically, what that whole unit was about was you have two lines and you find out where they meet. Well, we're going to do that today, but with a line and a parabola. So I have graphed the quadratic function minus x squared plus 6x minus 5. I've graphed it on the grid here. You don't have to do anything. I've already graphed it for you guys. We're going to graph the linear function 1/2 x plus 5 and just see where they meet by graphing them. Of course, everybody remembers y equals mx plus b and how to graph a line, right? Yeah. So I'll help you with this one, though. I'm just kind of kidding. Most of you guys probably remember. But this is a linear function. So 5 is our y-intercept. And 1/2 is our slope. And so let's graph our line. So we start at 5. And our slope is 1 over 2. Up 1 over 2 all the livelong day. Fill up your graph with more points. Up 1 over 2. Up 1 over 2. I'll go back 2, down 1. And I think I won't test out the fine motor skills today. I think I'll use my straight line tool. You guys can just do your best impression of a straight line. Do grade 11s even pack rulers anymore? I don't know. Now, everyone, does that line and that parabola, do they meet anywhere? They don't meet anywhere. So would you guys agree that it's possible for a line and parabola just to never meet? Okay, that's our first case. In this case, they don't meet at all. There's no points of intersection. No points of intersection. So that's one possibility. And I'm just going to start calling points of intersection POI just to save myself some writing. All right. Well, in the second box, I've got another linear function. Let's see if it touches and meets this parabola at all. So this linear function has a y-intercept of -1, and the slope is 2. And I might just add here, you can write 2 is 2 over 1, so you have a rise and a run to plot. Can you guys graph that line? Do we meet this parabola? Do we not meet it? How many times do we meet it? Who can say? Who can say? So where are we going? We're starting at -1. And then we're going up 2 and right 1. And up 2 and right 1. Well, look at that. I think we touched. And then up 2 and right 1. Yes, touched. It's not inappropriate. It's just said touched. They met. They met at a point. Look, they met at a point. If we graph that line, you guys are going to get me demonetized here. Would you guys agree? It looks like this line meets this parabola just one spot. They just briefly meet. I wouldn't say touch, because obviously that sets you guys off. Yeah, it's possible for a line and a parabola to meet at just one point. And hopefully you're convinced. We just showed that here. We can actually say what point they meet at, because we graphed it, and we can see that they both meet. They both go through the point 2, 3. The point of intersection, or the POI, is 2, 3. So it's possible for a line and a parabola to never meet or to meet once. I wonder if there's any more cases that we could consider. So there's one more line down here for you guys. Same parabola, different line. The linear function, -1x plus 5. So the y-intercept is 5. and our slope is -1. So you can think of that as -1/1 if you want to draw. I wonder what will happen here. I wonder. So 0, 5. And then we'll go down 1/1. And then we'll just keep going. They touch. Then they touch again. Sorry, you give me a reaction, so I'm going to keep saying it. Yeah, it looks like this line and this parabola meet twice. That's very interesting. So let me just graph this line using my straight line tool. Very nice. And we can read off the 2 points that they meet. Looks like 5, 0 is one. And what's the other one here? It looks like the point 2, 3. Would you guys agree that they meet at those 2 points? So it looks like it's possible for a line and a parabola to meet 2 times as well. So we'll say there are 2 points of intersection, or POIs for short. This time it was 2, 3, and 5, 0. So here's where we're going with this. In grade 10, both courses solved linear systems where you either graph 2 lines and found where they meet, or you, in both classes, you learned some algebraic techniques to find a point of intersection of 2 lines. Today, we're finding where a line and a parabola meet. We call this solving a linear quadratic system. Big fancy name for just saying we're going to figure out where a line and parabola meet. Now we've got one method here. We've done this by graphing. It's not always practical or possible to sketch our parabolas or lines, so we need an algebraic way to do this. So that's what I'm showing you guys today. All right, so just to summarize, there are 3 possible outcomes when solving a linear quadratic system. So outcome 1, you might get no solutions. And just over in the side here, you can just draw, like we had before, draw a line and a parabola that don't meet each other. Maybe on the other side, I'll draw something similar. There's lots of ways we can draw a parabola and a line such that they don't meet. That's one possibility. The second possibility is that there is one solution. And let's just draw a couple cases where we have one solution or one point of intersection. So we're just going to draw a line and a parabola where they just touch one time, kind of like so. I'll draw another one. Here's another one. So you can have no solutions, they never touch. One solution, they touch once, or you can have 2 solutions. But these are the only 3 cases. You can't have a line hitting a parabola 3 times. So let's just draw those same parabolas from up above and just draw 2 cases here. So maybe something like that, meet 2 times. Something like that, meet 2 times. I think that's a good visual summary. You guys believe me? Those are the 3 possibilities. There's no other possibilities. It doesn't matter if you believe me or not. Now I have a blurb here that's actually going to be something for our 3rd unit here. So you guys can just add a little note here. We might revisit this in unit 3, something called the discriminant. Okay. But what we're going to finish off with, I'm going to show you guys an algebraic way that we can find the point of intersection between a line and a parabola. And it's going to involve solving by factoring. So let's dive in. So you guys remember the last two? The last pair of line parabola, they met at 2 and they met at 5, right? X equals 2, x equals 5. Gervin, Kemper, you guys okay? I'm just tired of talking over you guys the whole class. No questions at all? Okay. How could we figure that out algebraically if it wasn't possible or practical to make a sketch? Well, you guys are going to be YouTube famous now. Called you guys out in the middle of class. So, same two functions. How can we find the point of intersection or points of intersection? Here's the key idea. What we're going to do we're going to do this. We're going to set the two functions equal and solve the resulting equation by, I was going to see if I could squeeze it on there, by factoring. It's all skills you guys already have. Really, guys, today there's really nothing brand new. It's just tying a bunch of things together, which is like most days in math class. So when you set the two functions equal to each other, it's just literally on either side of an equal sign, you put the linear function stuff, you put the quadratic function stuff. This is the quadratic equation, and we can solve it by factoring. But guys, it's not quite ready for us to solve by factoring yet, because we need to have like one thing times another equals 0. And right now, we don't have 0 on either side. We just got some stuff on this side and some stuff on this side. So we have to get everything onto one side, make everything equal to 0. So here's a piece of advice for you guys when solving a linear quadratic equation. When you guys are factoring, it's much easier to factor things when the squared term is positive. So what we're going to do is, even though it's one more extra thing, we're going to take all the terms on the right-hand side. And I'm just going to visualize it like this. I'm just going to do boom, 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 3 arrows. We're going to move all those terms to the left side so that we can collect them with the other guys. So all I'm going to do is I'm just going to move over minus x squared, change the sign, positive x squared. 6x crosses the equal sign. Now minus 6x, minus 5, move across, plus 5. And then we still have our minus x plus 5. And now, on the right-hand side, we've moved everything over. Nothing is left, equals to 0. And let's collect some like terms here. So we have 5 terms here, only one x squared term though. So when we add like terms together, we'll have x squared. And then we'll have, I don't want to make my sheet too clunky here. You don't have to underline like terms if you don't want to, but we have minus 6x and minus x. Those combine to make minus 7x when you add them. And then 5 plus 5 is 10. So we're just adding the numbers. 5 plus 5 is 10. And look, we get this nice, tidy little quadratic equation that we can solve by factoring. It's a simple trinomial, doesn't take a lot of effort. And I will say, I think many of you guys in this class could probably just go right from moving the terms over and go right here. But I'm not your dad, do what you want. Show all the steps you need to feel comfortable. And at this point, we're just solving by factoring. It's a simple trinomial. So what adds to minus 7, what multiplies to 10. X and X, both have to be negative. Anybody get the two numbers yet? Sam got them? Minus 5 and minus 2, or minus 2 and minus 5, whatever you prefer. And again, many of you guys will be able to see the two answers right away. But let's just show our work here. What makes x minus 5 equal to 0? X equals 5. And what makes x minus 2 equal to 0? X equals 2. So the grand conclusion, the line and the parabola meet twice when x equals 2 and x equals 5. Now that's just what the x values when they meet. And if you guys will humor me, we'll flip back to the previous page here. Would you look at that? Our line and parabola met when x was 2 and when x was 5. Really, I'm just concerned with the x values where they meet at this point. To find the y values, we can just plug them in. But yeah, we got the same answer, right? Both ways. And it's all skills you guys already have. Set the two equations equal to each other, move the terms around, and then solve by factoring. Everybody can do this. I believe in you guys. Anything you guys want to chat about? We're going to do one more together, possibly two, and then give you guys some options on what to work on. Some of you guys have some work to do. So in this example, we're going to solve it by graphing so that we know what to expect. And then we're going to solve it by factoring. Now, I believe this is just recopying what we had on the front page. We already did this one, right? Or at least we already graphed it, so we know what to expect. So I know you guys already did this. 2x minus 1 looks like this. I know we already did it, but we're just getting this visual onto this example here. All right, so point of intersection, we already knew this. We're just copying it down to this practice one. The point of intersection, there's only one at 2, 3. So when you guys apply our new method here, and when we solve our equation for x, we're expecting to only get one answer. So that's interesting. Let's see how that plays out when we apply our new method. All right, here we go. So I've already given you guys that first step of setting our line and parabola equal to each other. We don't like a negative quadratic term, so we're going to move everything to the left. Whether you do this in one step or multiple steps, up to you. I'm going to show it this way. Moving over my 3 terms changes their sign. And then 2x and minus 1 are still here, so they just have the same sign. And everything now equals to 0. Collect the like terms. We got x squared minus 6 and 2 make 4. Minus 4, minus 4x. And 5 minus 1 adds to 4. You guys can now solve by factoring. We're only supposed to get one solution. I wonder how this will play out. Who can say? Now, most of you guys do not prefer using the perfect square trinomial pattern. So we can just factor this one as a simple trinomial. What adds to minus 4 and multiplies to positive 4? So both numbers will be negative. What numbers add to minus 4, multiply to 4? Negative 2 and negative 2. Look, the same bracket twice. You could also write that as x minus 2 squared. We only have one thing to set to 0. And guys, we did it. They meet. When x is equal to 2. Exactly, guys, look at the graph. That's exactly what we said would happen, right? They've got one point of intersection at 2, 3. Now, because we have the space, can you guys just add this extra bit? Let's find the y value as well. So if you guys go back and look at the linear function, f of x equals 2x minus 1. So let's look at the line. And let's find the y value. Let's find f at 2. When you guys plug 2 into that equation, you get 2 times 2 plus 1. Because the equation's 2x minus 1. We're plugging in 2. And we get a y value of 5. Does that line up with, did I do that right? Oh, it's 2x minus 1. That's why there were more blank stares than usual. 4 minus 1 is 3. Now, if you guys look at the graph, do they meet at 2, 3? Is that the y value where they meet? 2, 3, right? You could also, if you check out, if you put this in the quadratic function and plug in 2, you get minus 2 squared. My memory sucks. What's the function? It is plus 6x minus 5. And then we do plus 6 times 2 minus 5. We should also get 3 if we plug it in there. 2 squared is 4, and make it negative. That's minus 4. 6 times 2 is 12. Minus 5. Hey, look at that. Minus 4, 12, and minus 5. We get 3 as well. So I'm going to add in brackets down here and just add the point of intersection is 2, 3. So we just kind of showed how to get the y value too. When I give you guys a question like this on a test, though, I'm just going to keep it to the x values, usually just to save some time. But yeah, we've got a nice algebraic method here. You guys have the tools already. It's just solving equation skills from your grade 10 course, a little bit of factoring. We can all do it. So at this point, I'm going to give you guys a few options. So first of all, I'm going to come around and I'm going to personally tell each person in the room what you owe from the week before the break. That would be priority 1. Our test is Friday. I got to give the stuff back. And once I give it back, I got to pop it as 0 because the solutions are out there. If you're done all your outstanding assignments, you can keep working on the practice in this document. Or if you're feeling good about everything, I've got your cheat sheets. You can keep adding to it. I've also got a bonus task. I've also got some extra practice. I got a lot you could do. But really the priority should be your assignments and then practicing today's stuff. Okay? So you guys can keep working on that. I'm going to come around and chat with everybody. And then we got lots of time to work. We'll end the video.